Welcome to the next video, this time about the particle emitter editor. About this editor I've done already a couple of videos, but not directly about how you edit, so I hope I can keep it a little bit shorter this time. So the editor is just used to make anything that has to do with particles, and particles in this engine are in main about physical particles. So if you have more animated particles, that's more something for directly animated systems than for the particle emitter. That's a little bit more specific in how it works. So here is my editor. In general it's composed of the view, the properties and the different curves you can use. In general just add some cat type, let's say bloop, don't know, something like that. Give it a skin. In general it's the same as with other editors. We can use anything as a skin that we have. So this texture properties also directly affect the particles. So what do we take? Let's say that one here. So that's a default setup. Then in general you have various kinds of properties you can use. I'm not going to demonstrate all in detail, just a couple which are important. The rest is more to do it on your own. So the general idea is that you have a set of particles for which you can define what they do, and they're more geared for physical interaction. So it's not like stacking modules or something like that. It's a little bit more simpler approach, which is easier to handle, and I think it gives enough freedom to work with. So in this case let's reduce the interval a little bit. We've got a bit too much of those. No, that's the wrong way. Let's make it a little bit less. So, and let's do it like this, better for showing. What I do up there, emit bursts, that's simply more to test how an emitter works if used with bursts. That's a continuous particle emitter, and bursts are more that make a burst of particles. So for example, if I say I use 10 particles, then with each burst there would be 10 which are sent out. Now this is not very interesting since they all fly out in the same direction. So let's keep it for the example. In general, most important are things like the cast angle, which give a little bit of variation in what direction they are thrown out, like here. So in this time it's now going to the back, and that's always the first value is the fixed value. So it's the basic value of the particle, and on the back, the second here, it's the spread. So how much the variation is from 0 to 1. So I have here a large variation, it would go all around from left to right. Let's give it a little bit more velocity so we see better what's going on. So it just jolts out in all kind of directions, and we can do this for everything. So let's put this back on 0. Same height, but say all around in any direction I want, as an example. So let's keep it a little bit as an example. So this is the basic principle, that you just give the initial values and the initial spread. Make it a little bit smaller. So that's the general idea. So I have the time the particle lives, the interval in which they are cast, the amount of particles that are cast each time, like here for example have multiple cast and so forth. And for everyone you can use value and spread. You have the size, the coloring, so particles can be colored using this. By default it's white, it's just multiplied with the texture you use. That's more important for certain effects, the transparency and emissivity. This one is most important since you've got two styles of particles usually. Those which are lit by the environment, and those which are lighting themselves. So usually everything that is science fiction like or magic balls or whatever they have the emissivity set up, so that's usually what you need, and that's what is most time used. The rest, best just use it. Brown motion and stuff, that gives just a random direction, so I can also disable the gravity, for example. If I say local gravity 1, then it's just the gravity disabled, and here the brown motion can also be nicely seen, which just alters the motion of the particle. Let's give it a little bit extremely, so you see how it starts to whiz around without knowing, so it's random direction each time. So let's go back. The rest is a little bit less important. These are better just experiment with them. Reference might be also interesting. It determines how the bounces off the ground, but that's with these particles not that important. Okay, so that's basic. You can also use multiple types, and each type can have a different property, like for example I can say poof, and for poof I can say I take let's say, what have you got here? Oh, do we have something that looks like a puff? Well, let's take something else, doesn't matter. What do we have? Something like that. So you can mix them all in one. Now, important on the design is also the controls here. The controls allow to define, similar to the animation editor, a controller. Let's say speed, for example, between 1 and 10. Works the same as animators, so it's just the range you use. And then I can, for example, say let's put it on 0, so it's a little bit easier to look at. We take the linear velocity and say we want to control the value with our controller. So I can now say take the value, let's put up a value like this. So now the controller uses this curve of value to alter. So the curve controller value is mapped here, and that's the output. So the output is multiplied with this value, just so you see it. This way I can use a 0 to 1 range, but it's up to you. You can use larger or smaller. And if done this way, you could alter the speed just using the controller in this case. So the idea here is the same as with the animator editor. The animator and the programmer just agree on a set of controllers, but how it is implemented on both sides is completely free. The same you can also do for the spread. I could also go and say I take a spread. So let's say I remove that one here. Linear velocity is just 5. But I say the spread goes 4. And I can say I take the speed as control value and spread it. And now the control value would say how much the spread is influenced. If it's 0, all drop on the same. Let's take the interval a little bit higher so we see it better. So all are the same. And if I increase the controller, the speed difference increments. So you can map the controller to different types. The plus sign also gives you an idea which curves are set, and you also see directly which curves are used. So you have an overview. Last but not least, you can make the progress. So for example, along the size, let's say emissivity. If we take it so, then it's lit. And I can say the progress, I make a curve, so it's not lit, then lit a lot, less, a lot, less, a lot. So I can alter how the emissivity goes along the lifetime of the object. And beam is a little bit special. The last video about beams I've shown how this affects the value along a beam, which is a particular kind of particle. So that's basically the idea. You control the controllers, and with this you can alter your particle emitters. Then you can also use models and skin. For this I take now an example that's a little easier. Let's say mesh cast. So you see here, for this one I use the cube, and it casts away or uses the normals of vertices to cast. Or I can say it uses, if I would use the right mesh, so it uses vertices, the faces of the mesh. So the particles are distributed along the faces of a mesh, and you can theoretically also say volume, but this is not directly implemented since it's a little bit complex. So currently you have these two at your disposal. Then you have also a possibility to make, let's take this one here, the truck. So these are trails. Trails are under this section, so you simply define what particle emitter is used as the trail, and you can alter the particle emitter using these parameters. So you simply map, for example, the velocity to the first controller in the trail. So this way the linear velocity would affect parameters of the particle. That's a little bit more special, better experiment with it yourself. This is more complex. And another possibility are collision ones. No, not this one here. Let's take, what do we have? I thought it's this one here. Let's do it like this then. Let's take just something like that. I can say on the collision I make destroy and use the particle emitter bounce test. And now whenever a particle hits, it creates these particle emitters, and you can also control the controllers using particular properties. So in this case the speed would affect a controller, which affects how large the burst is. So again, a lot of possibilities. And here you also see you can use destroy or physical weapons. In this time it would bounce and emit multiple times. So these two are convenience. You could also just tell it to use your game scripts, but usually it's easier to use those. So that's for this field in the controllers. About beams I'm not going to say much. We had this already in the previous video, so you just know it's this kind of stuff you can use using the beam type. And I've done a video with a lot of these examples, so I'm not going to show it too much. It's more or less the beam curve here, which is new. But better watch the video that is pinned there. It contains a little bit more examples. Now we have, last but not least, have we something more? No, I would say that's more or less the best part. What you can also show is a little bit about additional properties. So you can use all kinds of material properties. You can also use for all other kinds of objects. So everything at your disposal. Something like this is just as easy to do like anything else. So really it's just using whatever you want, how you want to use it. So just create first your skins, and then you can simply create your particles with. And theoretically you can also use dynamic skins, but that's a little bit more special. And last but not least, perhaps showing how this actually would work if you use it with the controllers. A little flame here, and with the strengths you can, for example, control different properties. That one looks not so good. This one is better here. Wow, look at that. You can control different properties. In this case, the various parameters. So one controller can affect multiple curves and multiple properties. So the idea is really to allow you to alter particles easily. That's one of the main strengths of this system. Okay, I think that should be for the moment. Yeah, the rest is not so important. Just experiment with it if you have the chance. So, until the next time, have a nice day.